The first term of an arithmetic series is 25. Let's write this down. So that means U1 is equal to 25. And the fourth term is 13. So U4 is equal to 13. The sum of the series is minus 119. So the sum of the whole series is minus 119. And we're asked to find the number of terms in the series. So we are being asked to find n. So let's think about our formulae that we know. We've been told something about the sum. So Sn is equal to n over 2 times 2u1 plus n minus 1 times by d. And we've been told something about un, so let's write down that one as well. Un is u1 plus n minus 1 times by d. So we know that negative 119 is going to be equal to this. So we can plug that in. So we know that negative 119 is equal to n over 2 times 2 lots of u1, so 50, plus n minus 1 times by d, which at the moment we don't know. So now we've got an equation in n and d. Can we figure out what d is to be able to substitute it in here? Well, yes, we can. We can do that using the u4, using this bit here, because we know that 13 is equal to u1, which is 25, plus n minus 1. Well, we're in u4 here. Write that there. u4 is equal to all of this. So this is going to be 3d. Take away the 25, we get minus 12 equals 3d. So d is equal to negative 4. Well, now we know d, we can substitute that into what we had up here. So minus 119 is equal to n over 2 times 50 plus n minus 1 times by negative 4, which is our value of d. Let's multiply through by 2 and tidy this up a little bit. So we get minus 238 is equal to n times 50 minus 4 times n minus 1. So minus 238 is equal to n times, we got 50 minus 4 times minus 1, so 54 minus 4n, which, expanding this out and rearranging, is going to give us 4n squared minus 54n minus 238 is equal to 0. We end up with a quadratic equation. We can simplify this quadratic equation because all of these are even, so divide through by 2, 2n squared minus 27n minus 119 equals 0. I'm going to move over onto this side. Now, this quadratic equation, if we were in a calculator paper, we would type it in and solve it that way, but it actually factorizes this. Could be a non-calculator question, so let's do it as a non-calculator question. To factorize this, we know it's going to be 2n and n at the front of the brackets, and then we need to think two numbers that multiply to give 119 and add to give minus 27. Well, 119 is 7 times 17, so we're going to have 7 and 17 in here in some way. And we want them to add in some way when multiplied by the 2 to get us to minus 27. So if we had it like this, that would be minus 34n, and then plus 7 would give us minus 27n. So this is our factorized form, which implies either n is equal to minus 7 over 2, or n is equal to 17. But given the context of this question, this answer is not possible for two reasons. N can't be negative because it's the number of terms in a sequence, and n also can't be a fraction because it's the number of terms in a sequence. So it's not this one. So our answer is the number of terms in the series is 17.